Hello everyone, myself Samaralatnam Srivani Sharma. I'm currently pursuing my master in food processing technology at Banaras Hindu University, and today I'll be giving a presentation on the topic drying, grain drying methods and equipments. First, coming to the contents of my slides, here is the contents of the slide. First, introduction. So what is drying? Drying refers to the removal of moisture from grains and other products to a predetermined level, which provides a safe level to store the grain for longer period of time. The predetermined level of moisture removal retains the nutritional quality of food materials and prevent it from over-drying, which can deteriorate the nutritional composition of food materials. Drying is one of the oldest methods of preservation and protect grains and other products against attack of insects, mold, and other microorganisms during storage. Dehydration is referred to as removal of moisture from grains to a very low levels, usually bone dry condition. These are the different types of grain drying methods. Coming to conduction drying, when the heat for drying is transferred to the wet solid mainly by conduction through a solid surface, usually metallic, the phenomenon is known as conduction or contact drying. In this method, conduction is the principal mode of heat transfer and the vaporized moisture is removed independently of the heating media. Contact dryers can be operated under low pressure and in inert atmosphere. When agitation is done, more uniform dried product and increased drying rate are achieved by using conduction drying. Conduction drying can be carried out either continuously or batch-wise. Cylinder dryers, drum dryers are some of the continuous conduction dryers. Vacuum tray dryers, freeze dryers are the examples of batch conduction dryers. Coming to the convection drying, in this method, drying is dependent upon the heat transfer from the drying agent to the wet material, the former being the carrier of vaporized moisture. Steam heated air, direct flue gases of agricultural waste, etc. can be used as drying agents. Drying temperature varies widely. Convection drying is most popular in grain drying and it can be carried out either continuously or batch-wise. Convection drying is done under the fluidized state, under the spouted bed condition, and under ordinary state. Under ordinary state, we can use the natural or the unheated air, the air heat drying with a supplemental heat, or using of heated air drying. The basic comparison of these three convective drying methods are given here. The natural air drying has the advantages that it has lowest initial investment and maintenance costs, no fuel costs, least mold growth compared to supplemental heat drying. Disadvantages includes very low drying rate, weather dependent, more drying space necessary. Supplemental heat drying, the advantages include lower cost of equipment and maintenance, independent of weather and requires less supervision. Disadvantages include fire hazard to a certain extent, danger of accelerated mold growth, rate of drying is still low. In the heated air drying, advantages include independent of weather, fast drying, high drying capacity. Disadvantages include higher initial investment and maintenance costs, considerable fuel expenditure, danger or fire hazard. Coming to the radiation drying is based on the absorption of radiant energy of the sun and its transformation into heat energy by the grain. Radiation drying can also be accomplished with the aid of special infrared radiation generators, namely infrared lamps. Moisture movement and evaporation is caused by the difference in temperature and partial pressure of water vapor between the grain and the surrounding air. The effectiveness of sun drying depends upon temperature and relative humidity of the atmospheric air, speed of the wind, type and condition of the grain, etc. First, one of the most important radiation drying is the sun drying. traditional method of drying, and the drying takes place through the radiation mode of sun's electromagnetic waves. The solar radiation heats up the grains as well as the surrounding air, and this increases the rate of water evaporating from the grains. It is the most common drying method in Asia because of its low cost compared to the mechanical drying. Some of the drawbacks of sun drying is that it tends to be labor intensive and has limited capacity. Temperature control is also difficult in this method, and grains can be easily overheat, causing cracked grains, which lead to low milling quality. Coming to the another type of radiation drying, that is the dielectric drying. In dielectric drying, heat is generated within the solid by placing it in a fixed high frequency current. In this method, the substance is heated at the expense of the dielectric loss factor. The molecules of the substance placed in a field of high frequency current are polarized and begin to oscillate in accordance with the frequency. The oscillations are accompanied by friction, and thus a part of the electric energy is transformed into heat. The main advantages of this method is that the substance is heated at an extraordinary rapidity. Coming to chemical drying, various chemicals such as sodium chloride, calcium propionate, copper sulfate, ferrous sulfate, urea, etc. have been dried for the preservation of wet material. Wet paddy. Of this, common salt has been proved to be effective and convenient for arresting deteriorative changes during the storage. When wet paddy is treated with common salt, water is removed from the rice kernels by osmosis. The common salt absorbs moisture from paddy, but it cannot penetrate into the endosperms through the husk layer. Advantages includes that it not only dries the paddy but also reduces the damage due to fungal, microbial, and enzymatic activities and heat of respiration. Milling quality of paddy is satisfactory. Disadvantages include the moisture may be retained on the husk due to the presence of sodium chloride. The moisture of the husk changes to dark yellow. Coming to sack drying, this method is particularly suitable for drying of small quantity of seed to prevent mixing of varieties and conserving strain purity and viability. The grain bags are laid flat over holes cut on the floor of a tunnel system so that heated air can be forced up through the grains from an air chamber underneath. Usually, an air temperature of 45 degrees Celsius with an airflow rate of 4 meter cube per minute at 3 to 4 centimeter static pressure per bag of 60 kg is used for fast drying rate. Sacks are turned once during the drying operation. Coming to the grain drying equipments, these are the different types of grain drying equipments. First is the dip bed dryers. To operate the dip bed dryers, following rules have to be followed. That is, an airflow rate of 2.94 to 3.92 meter cube per minute per ton is recommended. Rates above 3.92 meter cube per minute per ton may result in uneven drying and is expensive in operation. If the moisture content of grains is up to 18%, the layer depth of grains should be limited to 3 meter. For grains whose moisture content is above 18%, the maximum depth recommended is 2.5 meter. In tropics where sprouting occurs in 48 days, deep bed dryers are not very successful. The net perforated area of the floor should be 15% of the total floor area. Next, we have the flatbed dryers. These flatbed dryers have the similar principle as that of the deep bed dryers, except that it has a wider surface area and a lesser depth of drying layer. The dryers are usually designed for farm-level operation, having 1 to 2 ton capacity. Grains are spread 0.6 to 1.2 meter deep over the perforated floors and dried. Advantages using these dryers includes the whole batch is dried quickly and there are less chances of spoilage due to molding. There is also less likelihood of overdrying of the grains, and a lower air pressure is required to force the drying air. Next, we have the continuous flow dryers. These dryers are columnar type in which wet grains flows from the top of the dryers to the bottom of the dryers. The rate of flow of grains column through the columns can be regulated by conveyors. There are two types of these dryers, which is the mixing and the non-mixing as shown in the figure. In the mixing type dryer, when the grains are diverted in the dryers, it is called the mixing type dryers. In mixing dryers, baffles are provided to cause the grains to mix during their downward flow. These dryers use air flow rate of 50 to 90 meter cube per minute ton and high drying temperature of 65 degrees Celsius. Zigzag columns enclosed by screens on both sides are used. In the non-mixing type dryers, if the grains flow in a straight path, the dryers is called a non-mixing type. In this, baffles are not provided and drying takes place between the two parallel screens. High airflow rates of 125 to 250 meter cube per minute ton can be used, and a drying air temperature of 54 degrees Celsius is used in non-mixing dryers. Next, we have the recirculatory dryers. This is a type of the continuous flow dryers, and it is a multi-pass procedure used to avoid the excessive drying stress. During its pass, the grains are exposed to the heated air for short time, which is 15 to 30 minutes, and about 1 to 3% of the moisture content is removed. Drying is faster and effective because of its continuous movement of the grains during the short drying times. In such dryers, drying temperature of 60 to 80 degrees Celsius is used. Between drying passes, the grains is stored in a tempering bin for 4 to 24 hours to allow the moisture content at the center and the surface of the grains to equalize. Coming to the LSU dryers, this was developed by the Louisiana State University in the mid-1950s and is called the LSU dryer. This design was developed specifically for rice to ensure gentle treatment, good grain mixing, and good air-to-grain contact. It is a mixing type continuous flow dryer in which layers of inverted V-shaped channels are installed. The layers alternate between hot air intake and exhaust air outlet and are staggered to provide mixing. The LSU dryer is of high capacity and being used in big commercial rice mills. Coming to the fluidized bed dryers, the principle of operation of fluidized bed dryer is to provide sufficient air pressure to fluidize a thin bed of grain or product, giving excellent air-grain contact. Above a certain pressure related to the wet per unit area of the grain bed, the pressure drop across the bed becomes constant with volume flow rate so that fast drying can occur. Advantages of the fluidized bed drying are fluidity of the bed facilitates continuous and easy equipment performance, lacking of moving parts and very good condition for heat and mass transfer provides good mixing. Next we have is the tray dryers. In tray dryers, many shallow trays are kept one above the other with a gap in between in the drying chamber. This is basically used for drying of vegetables and similar semi-perishable products. It has or may not have a perforated bottom. Perforated trays are used when the plenum chamber is at the bottom of the drying chamber. If the heated air is coming from the sides of the drying chamber, the trays may not have perforated bottom. The gap in between the group of trays permit air ventilation. Products are kept in thin layers in the trays. Lastly, we have is the solar cabinet dryer. The basic design consists of a rectangular cabinet, preferably insulated and covered with a roof of glass or clear plastic. Holes are made through the upper and base and the upper part of the cabinet. Perforated drying trays are positioned within the cabinet. Insulation passes through the roof and is absorbed on the blackened interior surfaces, which are then heated and warm the air within the cabinet. The warm air rises by convection and passes out of the upper holes. Fresh air, in the meantime, enters through the base holes. Coming to the conclusion, drying helps in proper planning of the harvesting season. It permits early harvest of crops, leading to the reduction of losses. Storage of products after drying makes products available during off-season. It provides an easy material handling. Also, the optimum moisture content of grains should be 14% or less. Therefore, dryers plays an important role in these days where food security is one of the major problems. Thank you all.